Okay, so the question is, if you have a cube and the side length of the cube is 3 inches, what is the length of the longest diagonal? So we want to look at two opposite vertices. So maybe we could look at this one and this one. And if we connect those with kind of a diagonal line, you can kind of visualize that that would be the longest diagonal, or it's the longest distance on the cube to connect those two opposite corners. So I'm going to assume that you're pretty good at using the Pythagorean theorem to solve problems, because that's what we're going to use here. But my hint will be to think about what happens if we kind of slice the cube diagonally like this. So what we'll end up with is something that looks more like this. Okay, so can you see what I've done? I've sliced my cube in half along this red plane right here. I've just chopped it in half. And now what I have is a triangular prism. That's half of the cube. And we can see that our blue line goes from the bottom corner to the top corner of the cube. So our blue line is now on the face of this triangular prism right there. So I know that this length here is 3, because that's part of the cube. So now I just need to find the length of this red line here. But notice that that red line is part of this triangle here, where we know the side lengths are 3 and 3. So we've got a right triangle. Here, I'll just kind of explode it out there. Right triangle, side lengths 3 of 3. And we can use the Pythagorean theorem to find this red length here. Maybe we'll call that length X. Very creative name, I know. So we'll call that red length X. So now if we look at here, we got another right triangle here. So maybe I could make some space for it up here. So that's this right triangle here on that slanted face that we chopped on the cube. So now I know I've solved for X. That's the red length here. This I know is 3. So now I can use the Pythagorean theorem again to find the blue length, and maybe I'll call that Y. Okay, I hope that helps. Good luck.